Section 12.3, logarithm functions. What is the meaning of the log? You have the exponential functions. F of x is 2 to the power of x. When we find the inverse of this function, inverse of exponential function is the log functions. How do we do that? Y is 2 to the power of x. Remember, to find the inverse, first we have to interchange x and y. So y is x and x is y. So this part, x equal to 2 to the power of y, now we have to write it in form of y equal log of x base 2. So that means if you take 2 and raise it to a number, the outcome is x. So log of x base 2 is inverse of 2 to the power of x. 2 to the power of x or exponential function, they all are one-on-one. Because remember, this part is the red one, it would pass the vertical and horizontal test. So to find the inverse, we draw the bisector, and then image of this is the blue one, which is the inverse. So we come up with the equations that we use it often in this section, and that is, if you have a log problems, like log of x base a is equal to a number, if you want to get rid of the log, that means you take the base of a and raise it to power of that. To summarize that, you don't have to use letter of m, a, and x, but what I do is I do have here that if you have a log of a with b of b equal to c, means these a, b, c can be any numbers, okay? That a could be any numbers. To solve the log problems, what comes after the log, whatever, if it's a number or a variable, you write that, and you take the base and raise it to number or what you have on the other side. Example, I want to know what is log of 10 with base of 10. That's the question. Means we don't know what the c is. But according to this formula, what you have after the log, which is 10, you write that, and you take the base and raise it to power of what you have on that side. So 10 to power of 1 is 10 to power of c. What is the value of c? 1. Like if I have 2 to power of x is 8, 2 to power of which number is 8? We know the answer is 3. 2 to power of 3 is 8. What you could do, you could take the 8, write 8 as, what is 8? 8 is 2 times 2 times 2, or 2 to power of 3. In a case that these two bases are equal, power has to be equal to each other. So x is 3. So let's say I have 3 to the power of x is equal to 9. How do I solve it for x? 3 to power of x is 9 is 3 to power of 2. So x has to be 2. So like this problems, 1 over 81 with base of 3 is equal to what? Again, c is unknown. So what you do is you just take, according to this, what you have after the log, you put that first, and you take the base and raise it to numbers on the right side. So 1 over 81, which is 81 to power of negative 1. Why? Because remember, 1 over x is x to power of negative 1. This is a formula. So if I have like 1 over 3 to power of 2, this is 3 to power of minus 2. If I have 1 over 3 to power of 4, is 3 to power of negative 4. All right? Or if I have 1 over 81, is 81 to power of negative 1. So here, we understand that 81 is 3 to power of 4. So when you multiply these two, 3 to power of -4 is 3 to power of 0. So C is -4. Like here, log of 81 with base of 3 is equal to what? Which is a C. Again, what you have after the log, you write that. You take the base and raise it to numbers on the other side. 81 is 3 to power of 4 equal 3 to power of C. So C is 4. After the log, I have 1. You write a 1 and 20 to power of C. But here, you understand that 1 could be any number to power. Any number to power of 0 is 1. So instead of 1, you could just write 20 to power of 0. So then C is 0. After the log, I have that equal 10 to power of C. And 1 over 1,000 is 10 to power of -3. 10 to power of C, so C is -3. So we are using this formula. See again here? Log of 4 with base of 16 is equal to what? Means C is unknown. 4 is 16 to power of C. 4 is 2 to power of 2, and 16 is 2 to power of 4. And if you have more than 2 exponent, you always multiply. See this formula, if you have more than 1 power, you could always multiply the power. So 1 power is 4, the other power is C. You could always multiply the power. 2 is equal to 4C, so C is half. Log of 4 with base of 4 is equal to what? Now, in this case, this is kind of different, these problems, because now there is another formula that we could use, that if you have log of x with base of y is log of x over log of y. You know, your calculator has a function of log here, this log. Let's say I want to find 3, log of 3. Log of 3. I want to find log of 17. Log is log 17. Calculator is able to find the log because the base of the calculator is 10. And we don't write the 10. So if you see, we ask you to find log of 3 and you don't see any base is always 10, is hidden. But if we ask you, okay, so what is log of 3 base of 10? Log of 3 base of 10 is 0.477, right? But if I ask you find log of 3 with base of 5, you cannot use the calculator because calculator is designed with base of 10, not 5. So now what you do is you change this to log of 3 over log of 5. Now both are, and then you find it separately. Then you just say, okay, log of 3 over log of 5. So if the base is not 10, you cannot calculate it, you cannot use the calculator directly because the calculator is just for base of 10. So if the base is not 10, is different number like this, then you do it like this, log of 3 over log of 5. So it would be log of 3 divided by log of 5. 0.6826. Okay, let's say I want to find log of 7 and you don't see any number here, means it's 10. Well, in that case, I'll just say, okay, it's just 7. You could use your calculator, just say log of 7, because the calculator base is 10, is 0.84. But if I want to calculate log of 7, let's say with base of 5, you have to change it to log of 7 to log of 5 first. And then you say log of 7 divided by log of 5. And it gives you 1.209, whatever. Okay, so that's what we use here for these problems. Here, what is log of 4 base 4? Log of 4 base 4 is log of 4 divided by log of 4 is just 1. So basically what you have is 4 to power of 1. What is 4 to power of 1 is what? It's 4. Now, next is how we want to graph log of x base 5. Again, remember, number after the log has to be positive, okay? You don't have log of negative number. Like here, I want to calculate log of -7, all right? So log of -7 is log of -7, okay? Is error, because calculator, the log after the calculator has to be positive. So what you have after the log has to be positive. Okay. So if I want to graph this, what you do is you could use the formula again and write what you have after the log is x equal 5 to power of y. And then remember, we just keep trying to put some numbers for y and find the x. Same thing here. The base is 4.2. So x is 4.2 to power of y. And then you try to have some numbers for y and find the x value. So you're using this formula all the time. S is equal to log of 13 with base. What is the value of s? 13 is 9 to power of s. They want you to write it in exponential equation. They want you to go from log to exponential. It means backward. This one, log of 0.001 equal to -4. Convert to exponential. If you don't see any base, base is always 10 if you don't see any number here. So see, so this number after the log is 10 to power of -4. They want you to do it this way. If you want to go backward from log to exponential, after the log you have s equal to k, the base to power of 4. Now, we talk about log of different numbers, like log of 7, base is 10, equal to number, log of 13, equal. What if you have log of like 5, but the base is e? What is e? E is a Neperian number, which is 2.77. If you want to use that, find that number in the calculator. It's like a pi. Remember pi was 3.14 in trigonometry? Pi was this constant number. We also have a number is e when you're dealing with the log. To find that number, here in my calculator, there is an e to the x here. I don't know if you could see it or not. There is this e to the x here. So let's say x is 1. So what you do is you go second e to the x. If I want to know what the value of e is, I'll just put 1 here, e1. So it's 2.c is a long number, 2.71828. Let's say it's 2.72. So e is 2.72. If you want to calculate log of 5 with base of e, or if you want to calculate log of 5 with base of 2.72, calculator, if the base is e, calculator would take this part See here, you don't have to calculate log of 5 based on log of 2.72. Calculator would take this part and change it to natural log. So natural log of 5 means log of a number that base is e. So in that case, you don't have to do this. So if I want to find log of, let's say 7 with base of e, you take this part and you just say it's a natural log of 7. Find the natural log of 7. What is natural log of 7? Calculator has here, ln. Natural log of 7. They give you the number 1.945. So all the rules that apply to log, they also apply to ln. So here they want you to change it from exponential. So what you have after the log is e to power of that. Here they want you to do it backwards. They want you to change it to the log. So log of this is 10 to power of 6. So that's how to change it to the log. How to solve it? How to solve this? What you have after the log is x, is 3 to power of 2. 9, after the log, you have 9 is 3 to power of x. And 9 is 3 to power of 2, so x is 2. After the log, I have 2. 2 is x to power of 1, so x is 2. After the log, I have x. X is 4 to power of negative 2. Remember, anytime you have a negative number, x to power of minus n is 1 over x to power of n. Don't forget that formula. So 4 to power of negative 2 is 1 over, 4 to power of 2 is 1 over 16. How to solve these equations? What you have after the log is 2 to power of 3, which is 8. So this is the equation, 5 minus 3x equal to 8, and you solve this equation to find the value of x. So in this 12.3, then you are using, I'll put a copy of this formula, then this is how to graph log by just plugging the numbers. This is the formula, which I show A, B, and C. They are using a different formula here, okay? And this is when bases are equal, the exponent are the same, like 2 to power of x equal to 4. This is very similar to that. All right.